Hi friends, today we'll talk about remainder theorem. This is a very important part of the chapter polynomials. Now, if suppose you are given with any division, be it arithmetic division or a polynomial division, and you are asked to find the remainder of the division, how will you do it? You will actually perform the division process, you will complete it, and whatever the answer you get at the end, you will claim it to be the remainder. Okay, but without carrying out the division process, is there any method in which you can directly tell the remainder of the division? Yes, you can tell using the remainder theorem. But one thing that you have to keep in mind, that remainder theorem works only for linear polynomials as divisor. That is, your divisor should be of the form x minus a, or in other words, your divisor should be of degree 1. Okay. So, I've taken an example here. Find the remainder of p of x by g of x equal to 3x square plus x minus 1 upon x plus 1. So, your dividend is 3x square plus x minus 1 and your divisor is x plus 1. So, divisor is a linear polynomial here. P of x is a quadratic polynomial here, and you have to find the remainder. So, first let's find the remainder using the normal long division process or synthetic division. First, I'll use the long division method here. So, 3x square plus x minus 1 divided by x plus 1. Okay. So, the first step is 3x square by x will give you 3x here. Okay. So, if you will multiply 3x into x plus 1, I'll get 3x square plus 3x. And then I'll reverse the signs. 3x square and 3x square gets cancelled. X minus 3x will give you minus 2x minus 1. Now minus 2x by x will give me minus 2 here. Okay. Now minus 2 into x plus 1 will give me minus 2x minus 2. I'll just reverse the signs. Minus 2x plus 2x will get cancelled and minus 1 plus 2 will give me 1. So the quotient here is 3x minus 2 and remainder here is 1. If you want to learn how did I perform the long division method, I have uploaded a video, so you can just refer that video of performing polynomial division using long division method. So the quotient here is 3x minus 2 and the remainder I got is 1. So now I can say definitely that this division has a remainder 1. Okay. Now let us find the remainder of this division without actually performing the division. So the first step is, first check if divisor is a linear polynomial or not. Okay, because remainder theorem works only on a linear polynomial if the divisor is a linear polynomial. Yes, divisor is a linear polynomial. So step 1 is okay. Now step 2, find 0 of g of x. That is, find 0 of the divisor. Okay. Now the step 3, replace x at p of x with 0 of the divisor. Now you substitute the found 0 of divisor in x, that is at px. Okay, so what the answer you will get will be the remainder. Let us verify this with the same example. So 3x square plus x minus 1 upon x plus 1. So the divisor is a linear polynomial. First step is checked. Now second step is find the 0 of the divisor. Okay, so how will you find the 0 of the divisor? X plus 1, g of x equal to x plus 1. You will equate it with 0. So the 0 of this divisor will be minus 1. Okay. What does the third step says? Replace x at p of x with the 0 of g of x. So the 0 of g of x is minus 1. Evaluate p of x here is 3x square plus x minus 1. Evaluate p of minus 1, that is the 0 of g of x. So you will get here plus minus 1 minus 1. This will be 3 minus 1 minus 1. That will be 2 minus 1 as 1. Okay, so p of minus 1 is 1. So this 1 is the remainder of the division process. And what did you get here? Same, 1 is the remainder. Okay, so how did I find it? Just a quick revision. First, you have to check that divisor is a linear polynomial. Second, you have to find the 0 of the divisor. And that 0, you have to replace it with the x at p of x. Okay, that is, you have to find the value of p of x at x equal to the 0 of the divisor. So the value you get is the remainder. So what is the definition of the remainder theorem? Let p of x be any polynomial of degree greater than or equal to 1. Okay, so the p of x dividend can be either a linear polynomial or a polynomial greater than degree 1, that is quadratic, cubic, whatever. Now, p of x is divided by a linear polynomial, say of the form x minus a. So the divisor can only be a linear polynomial of the form x minus a, where a is a real number. Okay, so what will be the 0 here? A will be the 0 of the divisor. So then the remainder is p of a. So if you evaluate p of x at x equal to a, whatever answer you get will be your remainder. Okay, that is what we saw here in this example. Okay, I have taken another example here. X cube plus 3x square plus 3x plus 1 divided by x plus 1. So p of x is a cubic polynomial here, and the divisor is a linear polynomial. We'll first use either long division or synthetic method to check what is the remainder, and then we will use the remainder theorem to see if the remainders are equal. Okay, so I'll use synthetic method here, synthetic division method. So the value of the k is here minus 1, and the coefficients I'll arrange on the top row 1, 3, 3 and 1. Okay, so the first leading coefficient comes as it is. Minus 1 into 1 will be minus 1, 3 minus 1 will be 2, minus 1 into 2 will give you minus 2. Okay, 3 minus 2 will give you 1, 1 into minus 1 will give you minus 1, and 1 minus 1 will give you 0. Okay, if you want to learn how synthetic division method is performed, I have uploaded a video, you can check that. Okay, so the remainder we got here is 0. Now let's see what is the remainder using the remainder theorem. So the first step is to check whether divisor is a linear polynomial or not. Yes, it is a linear polynomial. Second step is to find the 0 of the divisor. So 0 of the divisor x plus 1 is x equal to minus 1. Correct? Now evaluate your p of x at x equal to minus 1. So p of x equal to x cube plus 3x square plus 3x plus 1. So p of minus 1 equal to minus 1 the whole cube plus 3 into minus 1 the whole square plus 3 into minus 1 plus 1. Okay, so this becomes minus 1, this becomes plus 3, this becomes minus 3, this is plus 1. So everything gets cancelled and p of minus 1 equal to 0. So 0 is your remainder. That is what we got here using the synthetic division method. Okay, so a quick revision. What is the remainder theorem? If p of x is a dividend polynomial, which is a polynomial of degree either 1 or greater than 1, and g of x is the divisor polynomial, which is a linear polynomial always in the form of x minus a. Okay, so the 0 of the divisor will be a. And if you evaluate p of x at x equal to a, that is p of a should be your remainder. Okay, so the remainder should always be your p of a, given that a is the 0 of a linear polynomial. Okay, I hope this session was useful. I'll meet you in the next session with some other topic. Thank you so much.